Hello, Mr. Fry's geometry class. I'm taking a look at this quiz 7-2. It's not due till next week, as he stated in class, even though it is posted. I did see somebody had turned it in, so I don't know if you want to go back and make changes if that person wants to, or if they feel confident, go for it. I'm going to read through this and hopefully give you some clarification, a little bit of guidance. So we're looking at Unit 7, polygons and quadrilaterals. Number one, which quadrilaterals always have opposite angles that are congruent? So we have opposite angles congruent, so there could be more than one here. Parallelograms, rectangles, rhombi, or squares. And you're going to want to pause this as I'm going to just read right through it. Number two, which quadrilaterals always have diagonals that bisect opposite angles? Bisecting means making them equal, equal angles. They're bisecting them, so cutting them in half. Would that be parallelograms, rectangles, rhombi, or squares? There's only a couple of them that do that. So number two, I want to get a couple of them. Number three, if ABCD is a parallelogram, and I marked this all up with this information, AD is 14, EC is 11, angle ABC is 64, so this whole angle, I wrote it on the outside, ABC is 64, and DAC is 71, DAC is 71, and BDC is 25. BDC is 25, okay? We can see all that. Then get all these. So if you're looking for BC, BC is just going to be the same as AD. AC is just going to be 2 11s, so just 11 times 2, or 11 plus 11. C, DAB. Well, you're going to take, in order to find DAB, we know this one's 64, so remember this is going to be a supplementary angle, so you're going to take 180 minus 64. And that will give you your answer. And then the measure of ABD. ABD. Now there is an alternating interior angle there. You have the answer somewhere on that diagram because it's alternating interior angle, being that they're parallelograms. ACD. ACD, what you're going to do is you're going to take the measure of DAB, this one, and you're going to subtract 71 from that. So this answer that you got, minus 71, should give you ACD. And then FADB, that would be 64 minus the 25. The 64 minus the 25 would get you this angle, that ADB. Number four, if PQRS is a rectangle, and ST is 12, I marked that, and the measure of angle PRS is 23. Find each measure. So SQ, find what SQ is. SQ is going to be just 12 doubled, so you're going to 12 plus 12, or 12 times 2. PR. PR is going to be the same distance. PR is going to be the same as SQ. C, the measure of angle QPR. Well, there's an alternating interior angle there, so you have the answer already on this diagram. Okay, QPR. That's alternating interior angle with an answer you already have. Angle PSR. So PSR, that's just going to be, every rectangle has this angle. It's a right angle. What is a right angle? What's the measurement of a right angle? And then SQR, in order to find SQR, you're going to take 90 minus the 23. And in order to find angle PTQ, you're going to take 180 minus 23 minus 23. Because PTQ, these two would have been your 23s. So it's a triangle we're looking at here. So this angle right here would be 180 minus that, and you're going to get an obtuse angle. Looks obtuse too, so that works out. Number five, if JKLM is a rhombus, and I have all of this information, MK is 30, so I just went ahead and split it up, 15 and 15. NL is 13. and MKL is 41. So that angle right there is 41. Find each measure. So NK, I already have it marked for you. JL is just going to be 2 13s. Multiply them or add 13 and 13. KL, in order to find KL, you're going to have to do this, Pythagorean theorem, because KL, you know this side, you know this side, you know this is a 90-degree angle, this is the hypotenuse, so 13 squared plus 15 squared equals c squared. Figure that out, take the square root, and you'll get whatever KL is. I'm not sure if that comes out even or not. I did not do it, but that's how you do it. Letter D, measure of JKM. You're just going to take this bisects. So if this one's 41, that means that one's got to be 41 too, because that's that rule that bisects. That goes back up to number 2, which quadrilaterals always have diagonals that bisect opposite angles. Okay. Letter E, the measure of JML, you're going to take 41 plus 41, just going to add them. And because JML, these two are equal to each other. MLK, you're going to take 180 minus whatever that JML is, because that is going to be MLK. MLK is this angle, so these angles are supplementary. Angle of MNL. MNL, that's just every rhombus on the inside. All those angles are right angles. What degrees is a right angle? Is what you're going to put here for G. And then KJL, you just take half of whatever MLK is. Whatever this angle was that you find, it's half of it, or just divide it by 2. Number 6, if WXYZ is a square with WZ equaling 27, find each measure. Well, ZY, in order to find ZY is going to be the same as WZ because it's a square. WY, in order to find WY, you got to do this. This is going to give you WY. Okay. You end up taking 27 squared plus 27 squared, and then that you take the square root of it and I guess just round it because it does not come out evenly. RX is going to be half of WY, so half of WY. Angle WRZ. WRZ, all angles are going to be right angles, so what measurement is that? E is XYZ, angle XYZ, so all the interior angles of a square are what? You put that there. Right angles again. What degrees is that? And measure of ZWY. ZWY. So what is half of the right angle? So that's what you're going to put there. That half. It's going to be half of these. Too. That would be your F. For number 7. Taking a look at CDEF. It's a parallelogram. CDEF. Find FCD. So what you're going to do, FCD, in order to find this, you're going to take this plus this, and it's going to, these are supplementary, so they are going to equal 180. Go ahead and solve for x. Once you find out what x is, after you isolate the variable and all that good stuff, plug it back into ECD, or FCD. Plug it back into there. Plug that value of x in there. 10 times it minus 23. That's going to give you the measurement that you want. Number 8, JKLM is a rectangle. JL, that diagonal is 2x plus 5. MK, the other diagonal, is 7x minus 40. Find MK, find the measure of MK. Well, you're going to set them equal to each other because they're equal. Isolate the variable on one side. Figure out what x equals, plug it back into MK. Plug that x value back in, so 7 times whatever your answer is, minus 40, and then you'll get the measurement for MK. Number 9, if PQRS is a rhombus, find measure of PQR. So PQR is this whole measure. Remember that these are going to be equal to each other because they bisect. they're bisecting. So that means, you know, they're the same. So we're going to set it equal to each other, isolate the variable on one side, figure out what x is. Then P, Q, R, what you're going to do is you're going to take that answer for x, plug it back into one of these, and then you're going to double it, okay? So plug it back in to, like, say, probably the easiest one is this one. Put your answer for x, whatever you figure out x is, 2 times it plus 7. Whatever that answer is, go ahead and multiply it by 2 because you're just finding half of it. Multiply it by 2. And then probably the hardest one, it's going to take you a while. You're just going to have to, you know, kind of trudge right through it. Quadrilateral BCDE has these vertices. You could get graph paper and look at it too if that helps you, and just plot those points. And determine the most precise classification of BCD, a parallelogram, rectangle, rhombus, or square. And then use the distance formula to justify your answer. The distance formula is this. And so you could start plucking away and, you know, call this x1, y1, x2, y2, and then, you know, find the distance between these 2 points, and then see the distance between, you know, pick this point and this point, rename them, you know, x1, y1, x2, y2, and then find the distance between those 2 points, then find the distance between these 2 points, and rename them x1, y1, x2, y2, and go through this formula, okay? Square root of x2 minus x1 squared plus y2 minus y1 squared. And just plug through that and see, like, if they're all the same distance, then you would, you know, say that they're a rhombus or a square. Or if you have two the same, opposite of each other, you know, it's maybe a rectangle. Okay, maybe you do need to draw it out to see for sure, but then you can get the distance using the distance formula. Either way, work on it. Don't worry about making mistakes. It is a test though, so do your best.